Okay, so for A, they just want us to plot the time versus the miles. And we're going by ones, so it'll be 0, so if we plot, this is what the curve is going to look like. So it's a smooth curve. So the part B asks us to find or estimate the velocity when t is equal to 1. So when t is equal to 1, we're going to estimate the velocity. Remember, the velocity is the same as the slope of the tangent line. So since we're estimating, we're going to estimate the slope of the secant line. So we're going to go from here to there. So we're going to use the points 0, 0, and 25 over, and 1 over 25. So we're going to put miles over time. And we're basically doing the y2 minus y1, x2 minus x1. So when t is equal to 1, we're going to have 25 minus 0 over 1 minus 0, which is 25 miles per hour. Okay, so that would be my velocity, an estimate of the velocity. When t equals to 2, we're going to do the same thing. So we need to decide whether this secant line would give me a better estimation or this one. And I think that one would be better. So I'm going to go from 2 to 1. So I'm going to have 55 minus 25 over 2 minus 1. So that would be 30 over 1, or 30 miles per hour. So estimation. So at t equals 5. Okay, so now we have right here. So we need to decide whether this is a better secant line or this one's going to be a better secant line. In this case, it doesn't really matter. They're both spot similar, so I'm just going to go from 4 to 5. You can also go from 5 to 6. In this case, it wouldn't really matter. So we have 190 minus 140 over 5 minus 4, which would be 50 over 1, or 50 miles per hour. Again, that's an estimation. If you would have done the 5 to 6, for t equals to 5, you would have got 220 minus 190 over 6 minus 5, which would be 30 miles per hour. So either one would be correct because you're estimating, so it's not going to be exact.